All right, let's dive right in. We're taking a deep dive into hydrogen today. You guys sent in a ton of research on hydrogen in space, and wow, let me tell you, I'm already hooked.
Yeah, hydrogen is fascinating. It's not just any element. It's kind of a big deal in the universe. Most abundant, powers the stars, even ties back to the Big Bang itself.
Seriously,
Yeah.
75% of the universe just hydrogen. That's mind-blowing.
It's true. That abundance, it's a direct line from the Big Bang. Picture this. The universe, just moments old, a crazy hot mix of protons and neutrons, right? As things cooled down, most of those protons, they just stayed protons. And that's the hydrogen we know and love.
So all this hydrogen's just hanging out. Then what? The research mentioned stars. Something about giant fusion reactors.
Exactly. Stars. Think cosmic power plants, and their energy source is hydrogen fusion. Deep inside, under crazy pressure and heat, hydrogen atoms are forced to fuse together.
The source material talked about two main fusion types, proton chain and the CNO cycle. What's the deal with those?
The proton-proton chain, that's what powers stars like our sun. Think of it like, I don't know, a slow dance. 4 protons, they slowly come together step by step to form one helium atom, releasing energy all the while. Now, the CNO cycle, that's more like a mosh pit, needs even higher temperatures to get going, uses carbon, nitrogen, and oxygen as catalysts to really speed up the fusion. That's what makes it work best in bigger, more massive stars.
Wow, so depending on the star size, different hydrogen fusion happening. There was even like a diagram of the actual reactions like HDE. I mean, that's incredible. The energy these tiny particles release.
Remarkable, isn't it? That energy release. That's what makes stars shine. But it's not forever, you know?
Yeah.
Eventually, stars start to run low on hydrogen in their core.
Oh, so then what lights out for the star? What happens when it's running out of fuel?
Not quite. It's more exciting than that. Picture this. The core's hydrogen, it's depleting, so it starts to contract under gravity. This actually raises the temperature. And what happens then? You get hydrogen fusion starting up in a shell around the core, kind of like a backup generator.
A backup generator. Wow, so the star's not done yet.
Not at all. This hydrogen shell burning, it makes the star's outer layers expand like crazy, turns it into, you guessed it, a red giant.
Ah, so that's how those are formed. Like a hydrogen swan song, leading to this massive transformation.
Exactly. And in the really big red giants, the ones massive enough, the core gets so ridiculously hot that the helium, the stuff made by hydrogen fusion, it starts to fuse too.
Wait, now the helium is fusing. What does that even do? Even more energy coming out.
Absolutely. Helium fusion, it creates heavier elements, things like carbon and oxygen, all the while releasing tons more energy. It's like the star's doing an encore, but even more intense this time.
So we've gone from hydrogen to creating carbon, oxygen, the building blocks of, well, everything. That's pretty impressive.
It really is. But hydrogen's influence, it doesn't stop there. It's a huge player in those vast spaces between stars, too. The interstellar medium.
Okay, tell me more about that. The interstellar medium, I'm picturing just a whole lot of nothing, but I'm guessing there's more to it.
You're right, there's a lot more to it. The interstellar medium, think of it like a giant cosmic tapestry. Gas, dust, radiation, it's all there. And guess what the main ingredient is? Hydrogen, of course. We're talking huge clouds, some of them hundreds of light years across. Just hydrogen.
Wow. Okay, so definitely not just empty space. What's it like in those clouds? Is the hydrogen the same as in stars?
It's similar, but, with some twists. You've got your neutral hydrogen atoms, just like in stars. But then you've also got ionized hydrogen. That's where the atoms have lost their electrons, blasted away by radiation from nearby stars.
So it's like a cosmic light show is stripping these atoms down.
Exactly. And then there's molecular hydrogen H2 that forms in the really dense, cold parts of these clouds.
Why is the molecular hydrogen so important? The research made it sound like that's where the really interesting stuff happens with star formation.
You got it. Those molecular hydrogen clouds, that's where the magic happens. They get cold and dense enough that gravity can start pulling the gas together. And eventually, boom, you get a new star forming.
It's like a cycle then. Stars die, they scatter hydrogen and heavier elements all over, that stuff collects into these clouds, and then bam, new stars. And hydrogen is the fuel for the whole thing.
Exactly. It's this amazing dance of stellar life and death, and hydrogen is right there orchestrating it all.
It really is incredible how this one element is involved in so many crucial things. Speaking of which, the solar wind, we touched on that earlier, it's mostly hydrogen too, right?
That's right. The solar wind, it's like this constant stream of charged particles, mostly protons shooting out from the sun's atmosphere. A constant invisible wind blowing through the solar system, if you will.
So our own star is constantly showering us with hydrogen.
You could say that, and it's not always a gentle shower either. Sometimes the sun, it lets loose with these bursts of energy and particles, we call them solar storms, and they can be really powerful.
Yeah, I've heard about those. Messing up satellites, causing blackouts, that kind of thing. Sounds kind of scary, to be honest.
It's definitely something we need to pay attention to, especially now with how much we depend on technology in space. Imagine a big solar storm knocking out our communication satellites or GPS. Not good.
Makes you think. Okay, so let's recap. Hydrogen giver of starlight, potential destroyer of satellites, and, as we've been discussing, a major player in how stars are born. Is there anything this element can't do?
It's not so much about what it can or can't do, it's more about the amazing roles it plays. Like, think about its connection to the very early universe, specifically this process called Big Bang nucleosynthesis.
Right, the research mentioned that.
Yeah.
Okay, I'm ready to go back to the beginning of everything. Lay it on me.
So remember how we talked about the Big Bang, this incredibly hot, dense mix of protons and neutrons? Well, Big Bang nuclear synthesis, that's the process that decided how those particles would combine to form the first atomic nuclei, the very first elements.
And hydrogen being the simplest element, I'm guessing it was kind of a big deal in this whole process.
You know it. Most of those protons, they just stayed as protons. That formed the massive amount of hydrogen we see everywhere in the universe today. Some protons and neutrons, they got together, made helium the second most abundant element, and then a tiny, tiny fraction they combined to create traces of lithium and some other light elements.
So by looking at how much of these elements are out there now, scientists can actually work backwards. Like, figure out what happened in those first few minutes after the Big Bang. That's wild.
It really is. It's like cosmic archaeology or something. We're using the amounts of these elements to piece together the history of the entire universe.
This is amazing. We started with hydrogen powering stars, and now we're talking about the origin of the entire universe.
Right.
I love these deep dives.
And there's even more. We haven't even gotten to hydrogen as a potential energy source for us here on Earth.
Oh, right. Fusion power. Basically clean energy from water. That almost sounds too good to be true.
It's definitely a huge challenge, but the potential payoff is huge too. If we can figure out how to make stable, controlled fusion happen using hydrogen isotopes, deuterium, tritium, those guys, it could be revolutionary.
Clean energy. Almost limitless. From a fuel source we could just get from seawater. Wow. Give me a second. I need to process all of this. From the Big Bang to clean energy, hydrogen really is the MVP of the universe. Fusion power. It's just incredible to me, the idea that we could actually harness the same energy source that powers stars.
It really is awe-inspiring, and it just goes to show how much more there is to learn about hydrogen and what it can do.
Speaking of learning, those search mentioned something about the very first stars, the ones that formed way back in the early universe. They were calling them population 3 stars, and they were nothing like the stars we see today, apparently.
That's right. After the Big Bang, the universe was mostly just hydrogen and helium, right? No heavier elements yet. Those were all made in later generations of stars. So you had this pristine environment, and that's where the population 3 stars formed. And yeah, they were probably much, much bigger than stars born later on.
Why is that? The lack of heavier elements that made them grow bigger.
Exactly. Heavier elements, they're actually better at radiating away heat. That helps cool and break up gas clouds. But without them, gravity, it just had free reign to pull all that matter together, and you got these monster stars. Hundreds of times bigger than our sun, maybe even more.
Wow, can you imagine? The light from those things must have been incredible. I'm guessing they didn't stick around for too long, though.
You're right about that. Those massive stars, they lived fast and died young. Spectacular supernova explosions, everyone. But here's the important part. Those supernovae, they scattered the very first heavy elements out into space. And that paved the way for the stars and galaxies we know and love today.
So even in death, those first hydrogen-powered stars, they were giving back to the universe, creating the building blocks for something even greater.
Exactly. It really shows you how everything is connected in the cosmos. Hydrogen, the most abundant thing out there, it played a crucial role in making the building blocks for everything that came after.
When we started this deep dive, we were just talking about hydrogen as the fuel of stars. But it's so much bigger than that, isn't it? It's the foundation of the entire universe, the spark that got everything going, the essential ingredient for stars, galaxies, even life itself.
It's humbling, isn't it? This simple element, one proton, one electron, that's all it takes, and yet it's woven into every aspect of existence.
It really is. And it makes you wonder, what else is there to discover about hydrogen? What secrets are still out there just waiting to be found?
Who knows? But each new discovery, it takes us one step closer to understanding the universe and our place in it all.
I like the sound of that.
Yeah.
Well, on that note, I think we've reached the end of our hydrogen-fueled deep dive.
It's been a pleasure exploring with you.
And to everyone listening, we hope you've enjoyed this deep dive as much as we have. We'll see you next time. But until then, keep those questions coming, keep exploring, and never forget, even in the vastness of space, the smallest things can have the biggest impact.